This is section 1.7, inverse functions. So informally speaking, inverse functions undo each other. So if I plug 4 into the first function and get 9 as an answer, I should be able to plug 9 into the inverse of the original function and get 4 as an answer. So if I go there, I get to come back. Not all functions have inverses, however, and the only kind of functions that do have inverses are called one-to-one. Okay, so remember before we go into this definition that a function, if we're thinking about our ordered pairs, if we start listing ordered pairs, if we have repeated x values, then we don't have a function. And for a function, you have to be able to pass a vertical line test. If you hit more than once, it's not a function. And if you were to think about the ordered pairs for those, they would have the same x value. For one-to-one, we have, it has to be a function still, but it has to go a little bit further. Formally, if different elements in the domain of f are assigned to different values, then the function is one-to-one. So if our x values are not the same, our y values are not the same. Another way of thinking about this is for a function, you cannot have a repeated x value. And in order to be one-to-one, you have no repeated y values. Okay? And if there are two distinct elements in the domain of f that are assigned to the same value, then it's not one-to-one. So if there are repeated y values for the ordered pairs, then it is not one-to-one. And similarly to the vertical line test, when you cannot have repeated x values, we have the horizontal line test for one-to-one. And if no horizontal line intersects the graph of the function more than once, then it is one-to-one. If it intersects more than once, it is not. Okay? So if I just think about, say, our basic cubic function shape, okay? This is a function because a vertical line passed through it will never hit more than once. It is also one-to-one because if you imagine passing horizontal lines through it, it never hits more than once. So this is one-to-one. 1-1 is very common abbreviation. But you could also have a very nice function, one of the easiest ones we deal with, the quadratic. So you have a parabola here. And it passes a vertical line test, so it is a function, but as soon as you start passing horizontal lines through here, you hit more than once. You have a repeated y value here, so this is not one-to-one. This is why if you can recognize your basic library of functions, you're going to know its basic shape, even if you don't know its specifics, and this is one of the things that you'll be able to recognize. So, full definition of inverse function along with its notation. Let f represent a one-to-one function. Then, if y is in the range of f, there is only one value of x in the domain of f, so that f of x is equal to y. Okay, so we define the inverse of f, which is denoted f to the minus 1. It is not f to the minus 1 power. It is read f inverse. It's f inverse of y equals x if and only if y is equal to f of x. Another way of writing this is f of f inverse of x is equal to x. We're going here later. I'm going to end up repeating myself. And f inverse of f of x is equal to x. In algebra, just think about it in algebra, how many times do we use an inverse of some operation? So if I add 2, then I subtract 2 later on. Knowing the inverse of something is very useful. And even more so here because we can find the domain of functions fairly easily, but finding the range is sometimes more difficult. But if you can find the inverse, then you have this nice relationship. If you didn't know the domain of f and the domain of F inverse, then you know the range of each as well, because the domain of one is the range of the other.